Hi everyone, we are Hanlu, Jiaqi, and Yanning. Our final project is Early Engineers, an engineering learning center for elementary school children. So engineering education is highly recommended and supported at the K-12 level, and children have an innate tendency to play, tinker, design, and create. However, the development of engineering education at the K-12 stage is still insufficient, and engineering learning itself is very challenging for elementary school students. So based on that, we decided to design a learning center to help children learn engineering better. So our target audience are American elementary school students in urban areas who have access to several museums, and the context is an informal learning setting for engineering education. So first, we'll discuss the design description. For the learning goals, we hope that the learning center can help children to learn some basic engineering knowledge, like the engineering principles and engineering problems. And we hope the learning center can also help them to deal with some more sophisticated design process, like how to optimize a solution by iterative testing and modification. And the learning center is designed based on the background story, and the basic scenario is that the planet we live in has become ill, and the children need to help the planet to become healthy again. So in the learning center, there are 8 levels. So each level has a certain topic like save energy and deliver food. And each level represents certain pieces of knowledge like the energy transfer and motion and power. And based on the story, each group of children will receive a progress map. So the progress map shows the real position of each level in the learning center. And after exploring each level, each group of children will receive certain stickers. And after collecting all of the stickers, they can receive the goal, which is to help the planet become healthy again. And we have designed 3 forms of activities, which are game, challenge, and workshop. So based on the topics and knowledge of each level, we will choose the most suitable form of activities for each level.
For the key design features, next slide. The first design feature, it highlights the scenario-based gamified learning. In our project, we have incorporated several gamified elements such as stickers, challenges, and adventures. The use of these elements with educational purposes can facilitate students' engagement and stimulate their learning motivation. Also, with adding scenario-based narrative, as research have shown that a comprehensive narrative structure can not only maintain children's engagement, but also make their overall museum experience more coherent and intelligible. Next slide, please. The second feature is about the use of technology to support visible engineering learning. In each challenge, we have incorporated different technologies such as friction sensors, force sensors, building toys with mechanical elements in order to display visual representations of abstract engineering knowledge. The use of these technologies is supposed to show the visibility of materials and process, which, as research have shown, that can encourage children to tinker and solve problems, as well as promote their collaborative interaction with engineering concepts.
Our center will have 3 primary interactions, and the first one is collaboration. Research shows collaboration will improve engineering learning, and female students prefer to collaborate to learn engineering. So to promote effective learning and encourage more females to participate, 3 to 4 children and their parents will form groups to complete tasks together. We also found that tinkering is an effective practice for engineering learning. The majority of our puzzles are designed to enable children to play around, test their ideas through trial and error, and constantly revise their design. Next. Additionally, research shows students will learn science knowledge better when knowledge-building scaffolds were provided, including knowledge prompts, peer ideas, and instructions for generating mutual agreements. Therefore, other than using technology to provide visible clues, our facilitators will observe children's play, ask prompt questions to help them reflect, and point out their misconceptions to help groups reach an agreement. Next. We will then walk through 2 use cases to explain how children will play in the center. For the puzzle pass through the dark forest, the story is children next need to create a hand-crank flashlight to cross a dark forest. The learning goal is to be able to explain the energy transfer process for a hand-crank flashlight. At the beginning, children will watch a video that introduces the importance of saving energy. The purpose is to help them understand how their project can contribute to the environmental protection. Next slide. Then group will sit at a round table. In front of them, there are huge dark forest posters with some hollows. Each of them will get pieces for the use of assembling a hand-crank flashlight. The facilitator will explain basic concepts first, such as how the motor works to generate electricity. During the process, the facilitators will walk around, observe children, and provide hints. For example, when children are stuck with how to launch the motor, the facilitator can say, think about how you pedal to drive your bike forward. Maybe you can turn the handle to pass your muscle power to the motor. The whole process allows children to tinker around with pieces, revise work, as well as try to observe and articulate the energy transfer process. At the end, children can plug the light into the holes of the posters, turn the handle, and try to lighten the forest. That will visually represent whether they successfully made a working flashlight and passed through the forest.
The second use case is called Build a Bridge. The goal of this round of challenge is that the users are supposed to build a bridge using straws and other materials we provided, and the bridge can carry at least 2 kilograms of coins. In this process, they can learn about the stability of different geometrical shapes and also learning about engineering design. The first step is that they watch a video together with their teammates and start thinking about questions such as what is the most stable shape in the bridge design. The second step that they start to tinker around with different materials and try out different shapes of the bridge structures, and then build their own design. The third step that after they have built their own bridge, they will need to test the strength of their bridge. There are 2 main methods to test. One is that they can use the 4 sensors we provided to test the strength of their design. And the second is that they can directly put the coins or weights on their bridge to test the capacity of their design. In the end, if their bridge can bear more than 2 kilograms of coins, then the users successfully pass this challenge and win the stickers.
So here are the references, and thanks for watching.